parallel lines. Okay, so let's start. Shortest distance between skew lines. What are skew lines? Non-intersecting, non-parallel. Okay, like this. Like this. Intersecting. Suppose A1 is the, you can say, the vector on this particular line L1, or you can say this vector has coordinates some x comma y comma x1 comma y1 comma z1, which passes through this particular line, or this particular vector lies on this particular line, and b1 is its parallel vector. Similarly, for L2 line we have a2 and b2. Okay, so shortest distance is actually if we just construct this particular vector, that is a2 minus a1, and here is one vector which is perpendicular to both b1 and b2, or you can say L1 and L2. So this vector's direction, you can say ratio, is given by b1 cross b2. This particular is a2 minus a1. So just the projection of this particular vector on this particular vector is actually the shortest distance. So in formulation we write like this. Okay, this is your shortest distance. Okay, so again I'm writing in next slide. So like this. Now for intersecting line especially, the shortest distance is 0. Okay, so actually for intersecting line there are two ways to check whether lines are intersecting or not. First, the way we discussed in last lecture, and second is checking the shortest distance. If it is coming 0, it means it is a intersecting line, like this. Now here you will have to find the STP, scalar triple product, of this particular vector a2 minus a1, this particular vector b1, and this particular vector b2. When you will form the STP of this, you are with this a2 vector, you are given with a2 vector, a1 vector, b1, b2. You have to just form the STP, and you have to make that STP 0. Here also you can say that the STP is also 0, because this particular is supposingly this is in capital A vector, this is a capital B vector, this is capital C vector, so it is forming the you can say STP, so like this. Okay, so STP is 0 for intersecting line. This is an important concept. Now for parallel lines especially, we don't have two different v1 v2, we have just both are equal to supposedly b vector. For this, the shortest distance is given by a2 minus a1 cross b over mod of b. Okay, magnitude of b. So like this, the parallel lines are there, and this is a1, this is a2, this is a common parallel vector to them. So like this you can write very easily. Okay, so this is the formula to find the shortest distance between parallel lines. Okay, now we discuss about one more concept. Okay, which is not in our today's lecture part, but we are discussing because in next lecture we have to discuss plane. So that is foot of perpendicular and image of point in line. Okay, image of point in line. Lines. So suppose the point given is particular to this particular line. So foot of perpendicular, this is perpendicular to this. So you have to just find, supposedly this is x1, y1, z1. Okay, and you have to find this particular foot of perpendicular. So what you have to do is you are given with this line. Okay, so just you have to make the direction ratios of this particular line and this particular line uh, perpendicular, and then their dot product will be 0. So you can let this particular point, this particular foot of perpendicular, using the general point on a line. You can take a lambda on a line and you write the general point on this particular line. That general point will be given the foot of perpendicular. Then you will find the direction ratio of this particular line and this particular line which is already given, and then you have to make the dot product 0, and when you will make dot product 0 you will get this particular especially the unknown, you can say lambda, because these points are also given to you. So thus then using that lambda you can write foot of perpendicular, and image will be located at just the double distance, or you can say foot of perpendicular is at midpoint of, suppose this is P, so midpoint of P and N, P and I, as simple as that. Okay, so this is your foot of perpendicular, this is your image, and it's very easy. In problem solving session we will take questions on this topic and then we'll discuss. Okay, one more concept we have to discuss, that is line of shortest distance. Suppose this is a line, this is A1, this is B1, B2 and A2. Okay, so line of shortest distance you can say is actually perpendicular. So actually you have to take points on this particular line. Suppose this is L1, this is L2. So you will take the general point on line as we discussed in last lecture, using lambda and mu as a constant, and then you will take the points on this particular line and this particular line. Then you have to find the direction ratio of this particular line, which is perpendicular to both L1 and L2. Once you will get that direction ratio, then you have the direction ratio of this B1 cross B2 also, which is perpendicular, which is same, that is perpendicular to B1 and B2. So you will just proportionate these two, can say values. Okay, you have to just proportionate it. Suppose this is coming as x1 y1 z1, but it will be in lambda and mu form, but still we can take x2 y2 z2, and suppose its coordinate at a b c, so like this, x2 minus x1 by a, so y2 minus y1 by b is equals to z2 minus z1 by c. Actually it will be in form of lambda and mu, so then you will find lambda and mu using this particular equation, uh, and when once you get lambda and mu, then you can write this particular coordinate and this particular coordinate, and then you have to take one coordinate and using that coordinate and the parallel vector, that is b1 cross b2, uh, its direction ratio, you have to just use both of them and you have to write the vector or Cartesian equation as per the need of that particular line of shortest distance. We will take the question on this also in our problem solving session. Okay, so I think it is clear to you, and this was all for today. In next lecture we will discuss about plane, and one more information I want to give you, that we will start a session on higher mathematics. Okay, that is your linear algebra. Okay, so very soon it will start. Thank you. Next lecture we'll discuss about plane.